We're now going to start our study of Chapter 2, which is Modeling Distributions of Data. Today's lesson is on describing location in a distribution. Our learning objectives for today are to find and interpret the percentile of an individual value within a distribution of data, to estimate percentiles and individual values using a cumulative relative frequency graph, and to find and interpret the standardized score, also called a z-score, of an individual value within a distribution of data. Here's an example. It's about wins in Major League Baseball for 30 teams during the year 2012. So you can see the stem plot there for the number of wins, and the key shows you that 6 and a 1 stands for 61. So the Minnesota Twins had 66 wins in 2012. How did they do compared to the rest of the teams? One way to answer this question is to calculate their percentile. In order to do this, we'll need to know the definition of percentile. And the definition of percentile is this: the pth percentile of a distribution is the value with p% of the observations less than it. You've heard this used before when you've gone to the doctor and maybe they plotted your height on a growth chart and they tell you that you're at the 60th percentile. So that would mean that you are taller than 60% of the guys or girls your age. So let's calculate percentiles for a few teams and their number of wins for 2012. So let's start with the Minnesota Twins, who had 66 wins. So here's 66. We see that there are 3 teams who won fewer than 66 games in 2012. So if we take 3 and divide by 30 for the total number of teams, of course that's 0.1. So that leads us to say that the Minnesota Twins were at the 10th percentile. The Baltimore Orioles and the Texas Rangers both won 93 games. Here they are right here. If you count the number of teams who had fewer than 93 wins, you will discover that it's 22 out of the 30 teams. And if you divide 22 by 30, that's 0.73 repeating. So they're at approximately the 73rd percentile. Another thing that we'll be interested in here is looking at percentiles for an entire distribution, and that will be given by what we call a cumulative relative frequency graph. It's just a graph of percentiles. It's also called an ogive, which is just a funky word to shorten cumulative relative frequency graph. Here's an example. I've given you an ogive that is for the major league wins. So this just shows a distribution of the percentiles. And here's a few examples of how you'll do this. You don't necessarily need to construct an ogive yourself. You just have to be able to read one. So here's a few questions. At what percentile is the team with 90 wins? So all I have to do is find 90 wins and go up to the graph and over to their percentile, and I find that that's, did I do that correctly, about the 90th percentile. If I ask you what was the median number of wins, then I know that the median occurs at the middle value, which is at the 50th percentile then. So I'll go to the 50th percentile, which is about here, and carefully go over to my graph and find out that that's maybe 82 or 83 wins. Another way to measure position is to find the z-score. A z-score tells us how many standard deviations from the mean an observation falls, and in what direction. Here's a formal definition for a z-score. If x is an observation from a distribution that has known mean and standard deviation, then the standardized score of x is, and we'll call it z, it's equal to x minus the mean divided by the standard deviation. A standardized score is often called a z-score. Here's an example. In 2012, the mean number of wins for teams in Major League Baseball was 81, with a standard deviation of 11.9 wins. So our problem is to find and interpret the z-scores for the following teams. The New York Yankees had 95 wins. So how do I calculate their z-score? I'll say z equals 95 minus the mean, which was 81, divided by the standard deviation of 11.9. And once this is calculated, you'll find that that is 1.18. So what does that mean? That means that the number of wins for the New York Yankees was 1.18 standard deviations above the mean. For the New York Mets, who only had 74 wins, their z-score is 74 minus the mean divided by the standard deviation. That comes out to be negative 0.59. That means that the number of wins for the New York Mets was 0.59 standard deviations below the mean. So what have we learned? We've learned to calculate percentiles, we've learned to read an ogive, and we've learned how to find and interpret a z-score. You should now go onto Blackboard and complete the quiz that's there.